Okay, we're going to be looking at the Unit 4 exam review. And I'm not going to work every single problem because that would be hours and hours worth of video that I'm not sure people would watch. But we're going to do sort of select problems within that review. This is the sheet that you will be getting on the exam on Monday. I will try to find a clearer version. I know this is a little bit tough to see, but these are the formulas that you're going to want to reference throughout the test. Of course, not all of them. Some of them you haven't learned yet. But for the most part, everything you will need will be on the front of this formula sheet. Okay, so we're actually going to start with number 1. Number 1 says to find the surface area of each of the given figures. And I'm going to try to color coordinate to the best of my ability here. I've got all my colored markers. And see if we can make some sense out of this. So the first thing we want to do when we want to find surface area is kind of ask ourselves, is there a formula for that? So just as a good general rule, if a triangle is involved, there's not really a formula for that. Okay, so if it is a rectangular pyramid, there's a formula. If it's a cone, if it's a sphere, if it's a cylinder, all of those are going to have formulas. But if there's a triangle involved, then you're going to have to break it apart into all of its different faces. Okay, so looking at this guy, I usually say, how many faces do you see? Okay, so in this case, we've got one in the front and the back, so that's 2. One in the bottom, that's 3. And then the 2 rooftop pieces, 4 and 5. Okay, so this particular one has 5 faces. So I'm just going to list 1, 2, 3, 4, and 5. And so I generally ask, what's the first face you see? And most people say triangle. That's the first face I see. So we're looking at this front face right here. So if we're looking at this front face right here, the shape is a triangle. And to find the area of this triangle, we need 2 measurements. We need to know how long is the base and how tall is the triangle. In order to be able to find the area of this triangle, which is base times height divided by 2. Okay? So then we can kind of quickly see here that this is going to be 3 times 4 divided by 2, or 12 divided by 2, which is 6. So my first face, this triangle right here, has an area of 6. And then, of course, if there's a triangle in the front, then there's a triangle in the back, and it has to be the same size for our prisms here. Okay? So you can see right here, there's a triangle in the back, and it has to be the same size. Okay? And so we're going to say the area of this is also 6. So first one is 6, second one is 6. Then we've got 2 more sides here that make up the rooftop part of this. So those are going to be 2 rectangles that are the same size to make up the rooftop. And if we look at this guy right here, here is one of those pieces. And you can sort of see here the dimensions that we need, base and height. My base is 15 and the height is 5. And so if I want to find the area of a rectangle, I'm going to do base times height, or 15 times 5, which is 75. And if one piece of the roof is 75, then the other piece of the roof has to be 75 as well. And you can see this is this piece back here, right here. Okay. And then there's one more piece, and it is the base that it is sitting on. It is also a rectangle. So it is this guy right here. Maybe a little hard to see because there's so much going on in this picture now, but maybe if I highlight this space, it's sitting on, you can see it. Okay, and so my base is going to be 15 along its long side and 4 along its short side. And so we're going to do base times height. So 15 times 4 is 60. And now I've found the area of all 5 individual pieces of this. So if I want to find the surface area, all I have to do is add up all these different sides, 6 plus 6 plus 75 plus 75 plus 60. Or remember, you can do 2 times 6 plus 2 times 75 plus 2 times 60. 5 minutes. Okay, so I end up with a surface area that is 222 square centimeters. So just adding up all the different pieces. Okay, so the next one is going to be the same. The only difference on the next one is you're missing a piece that you need in order to be able to find your surface area. Okay, so when we do this, and I'm just going to separate these two problems here so they don't bleed into each other. Okay. So same kind of thing here where we pick our faces, 1, 2, 3 that it's sitting on, and then 4, 5 to make up the rooftop. So I like to do this 1, 2, 3, 4, 5 because it keeps me from forgetting one of the faces as I'm finding all the individual areas. Okay, so as I begin looking at this, my triangle is actually a right triangle. So my height of my triangle is actually this piece right here, which is given. So this is going to be 5, and to keep confusion from happening here, I'm talking about this right triangle right here, and I'm just starting with the triangle faces. You can see there are 2 of them. They're going to be matching, kind of bookending, or bookends of each other. So it's sitting on 4.5, which will be our base, and its height is 5. So we can do 5 times 4.5 divided by 2, and that's going to get us our area. And so when we type that in, we end up getting 11.25 for our first area. And again, remember, there are always 2 triangles in this situation that match each other. So same exact dimensions means the area is going to be the same exact area. All right, so that's 2 of our areas. And then we've got 3 rectangles here. And so let's say, for the sake of conversation, we start with this one where it's the easy dimensions, this base rectangle. Okay, so this rectangle right here. And again, you can start with any one you want. It doesn't really matter. Our long side is 8 and our short side is 4.5. And so we do 8 times 4.5, right, base times height. And 8 times 4.5 is 36. So that's our next one. And then if this side is 8 and this side is 4.5, right? So we've got 4.5 here, we've got 8 here. Then I can very quickly see another rectangle there in the back. So this time I'm going to be talking about this rectangle right here, if you can see that. And so we can kind of see here its long side is 8, and then its short side is up here, it's 5. And 8 times 5 is 40. So that's our next one. And this is the one that people kind of struggled with all day today. This is this big flat one right here. Looks like this. Right? So if we were to highlight it or color in the whole thing, you know, it'd be all of this right here. Okay? So the problem here is when I go to write my dimensions, 8 is very obvious, but we need a height, which means we need one of these pieces. Well, the only way for me to be able to get that is for me to be able to do Pythagorean theorem. Okay, so I'm going to do a squared plus b squared equals c squared to solve for the hypotenuse of this right triangle right here. So we're going to do 5 squared plus 4.5 squared is equal to c squared. And when I type this in and just fit 5 squared plus 4.5 squared all is 1, I end up with 45.25 equals c squared. And then I take the square root of both sides and I end up with the square root of 45.25. You can actually work with it just like this. I went ahead and went to a decimal, 6.73, and approximated that value, but certainly if you wanted an exact value, you'd just be using the square root. Okay, so that means this length right here is 6.73. And now you can see the base and the height of that yellow rectangle, 8 by 6.73. So I just kind of quickly multiply base times height here, and I get 53.81 as the area of that big yellow rectangle, right? And then I can find surface area simply by adding all of these pieces up. So an 11.25, an 11.25, a 36, a 40, and a 53.81, giving me a surface area that is 152.34 square centimeters. Okay, these are actually the tough ones on the review just because there's so many pieces and so many tiny mistakes you could make in them. Okay, moving on to something a little bit easier, and I say easier because anytime you've got a circle involved, that means you have a formula that you can use, okay? So you go look up the surface area formula for a cone, and you find that it is pi times radius times the slant height plus pi times radius squared, okay? And if you remember from class, your slant height is from the apex to the edge, from the apex to the edge. The problem is in all of these, I didn't give you the slant height, L. I gave you the actual height, which is 7, okay? So you're going to have to use Pythagorean theorem in this problem to solve for L. So we're going to do a squared plus b squared equals c squared. And my two side lengths here are 3 squared plus 7 squared equals c squared. And if I type this into the calculator, 3 squared plus 7 squared, I get 58, doing 9 plus 49. And I guess I could be calling this L squared so that there's not multiple variables going on here because I'm solving for L. And then I take the square root of 58. I can leave it as 58, or I can go to a decimal. The decimal approximation for that would be 7.62. Or you can just plug in square root of 58 if you don't want to do that little bit of extra calculation. And then from there, I can plug straight into this formula right here. So at this point, I can say, okay, well, I can find surface area by doing pi, and I'll abbreviate 3.14, times my radius, which is given in the problem, 3, times my slant height, which is what I found, right? I solved for it and got 7.62, plus pi, and I'll abbreviate 3.14, times radius squared, or 3 squared. And I'm going to type it all in the calculator, all in one go. And I'm going to get that the surface area is approximately 100. And I'm just going to always go to hundredths here. So that means my surface area is approximately 100.00 square millimeters. Remember, surface area is always square units. Okay? So let's do that one more time. And the only difference between these two, and the reason I'm actually working a second one here for you, is that instead of giving you radius, I gave you diameter. So you will have one extra step in this problem. But you're going to use the same formula because it's the same figure. So you're going to say, okay, I know slant height. I know surface area is pi times the radius times slant height plus pi times the radius squared. And I'm looking for slant height here. So this is my slant height here, L, which I don't know, okay, because I gave you actual height, and I told you the actual height is 4. And this is where you're going to have to solve for the radius, okay? So in order to solve for the radius, you're just going to do diameter divided by 2. So you're going to take that diameter, 3.5, and divide by 2, and you're going to get 1.75 as your radius. But again, the issue here is I don't know slant height. So what I'm going to have to do is I'm going to have to use Pythagorean theorem again in order to solve for the hypotenuse and get my slant height. All right, so a squared plus b squared equals c squared is my Pythagorean theorem. And I end up with 4 squared, that would be my first side, plus 1.75 squared equals c squared. And when I do 16 plus 1.75 squared, I get approximately, or maybe exactly, 19.0625 is, and I've done it again, I've called it C, but actually I think I want to call it L, since I am in fact solving for L right here. And then I take the square root of that 19.0625, or I'm actually taking the square root of both sides because I always have to do that. And I end up with approximately 4.366 as my slant length right here. So 4.366. And once I get that, then I have everything I need in order to be able to plug into the formula and get an answer. So my slant height, oh my gosh, I did it again. My surface area is going to be pi times the radius, which I found to be 1.75, times my slant length, which I found to be 4.366, plus pi, 3.14, times my radius, 1.75, squared. And I type that all into the calculator to get an approximation for my surface area as 33.61 square inches. All right. One more in this particular video talking about surface area. So I'm going to jump to number 7. Number 7 is a pyramid instead of a prism. A pyramid instead of a prism, but we do the surface area the same way. Okay, so when I'm looking at surface area here, I'm noticing that I have, again, 1, 2, 3, 4, 5 faces. But with a pyramid, you're kind of guaranteed that you're going to have a lot of the same, okay? And I always say with a pyramid, start with that base, right? So this base is 3, and actually I'm going to put that inside to save room here. 3 that go in this way and 2 go in this way. And so my base of my pyramid, which is this shaded piece right here, is going to be 2 times 3, or 6. Okay. And from here, this problem actually gets kind of tough. So what happens now is I start looking at these side triangles, right? Remember, opposites are going to be, this is going to be the same as this, and this front one's going to be the same as this back one. So let's say we start with a front triangle. Well, the problem is I have no idea what the height of this face is, okay? And so I have to imagine, I've only given you the actual height, that there's a right triangle in here. So I'm actually pulling out a right triangle, so I've just turned it to the side for you, where this is going directly in the middle. So its base is going to be in the middle of this, which is only going to be 1 unit long instead of 2. And then its height is 6. So I'm talking about this triangle right here, which has a base of 3 units, but it's, I don't know the height of it. So that's what I'm solving for here with Pythagorean theorem. So 6 squared plus 1 squared is going to be my c squared. 36 plus 1 is 37. And I take the square root of both sides, and I end up with it being approximately 6.08. So very close to the normal height. That's 6.08. There we go. And so I'm going to get my area by doing base times height divided by 2. And when I do that, I get, let's see, 3 times 6.08 divided by 2, 9.12. And I will have 2 of those, one in the front and one in the back. And then I have 2 more triangles, and I have to repeat this process. Okay, so if I if I consider, we'll make a Christmas pyramid here, red and green. This triangle on the side, again, I don't know its height. I know the base. The base is 2. But I don't know this height on the face. So again, I have to drop to the middle and create a right triangle, okay, where the base of it's going to be half of this base, or 1.5, and the height's going to be 6. So it's going to look like 6 squared plus 1.5 squared is equal to c squared. And when I add 6 squared plus 1.5 squared, I get 38.25 equals c squared. And I take the square root of both sides, and I end up with 6.18 for my hypotenuse length. Not a lot different than the actual height, but it is slightly different. So 6.08, the height of that face. Oh, no, I'm sorry, 1.8. So to find the area, I'm going to do base times height divided by 2. And actually this happens, so I just get this. And I have 2 of those, one to the right, one to the left. And then, just like the previous ones, I can add 6 plus 9.12 plus 9.12 plus 6.18 plus 6.18. And I end up with a surface area of 36.60. And it just says units, so I'm going to write units squared. All right, I hope that helps you on those first set. If you need more help, find the next video.